Hello, and a very warm welcome to one and all present here. Today, I am Laksh Mittal, your host for the day. I am enthralled to host today's live session with masterclass, which we are brought to you, which is brought to you by Recurum. Our vision at Recurum is pretty simple. It is to onboard a million of enthusiastic users to the Web3 revolution, and that is why we bring to you this one of a kind masterclass, transitioning into Web3. The world is heading towards a very close knit and a connected ecosystem. And as time passes, different industries, different fields are trying to work together to reach higher places. And this is where Web3 comes to the folklore, to the first and front. Web3 is all about building communities through the power of decentralization, blockchain, and the secret sauce. It is that time, yes, it is that time that you, me, and the world transition into Web3. But before we get started, okay, with our new masterclass for today, let me tell you what Requiem actually does. Web3 is the new internet and is meant for anyone and everyone who wishes to be a part of a transparent, efficient, and autonomous ecosystem. This is where Requiem steps in and helps attendees from events discover Web3 opportunities like jobs, internships, remote work from various events like masterclasses, webinars, meetups, conferences, etc. To keep it very simple and in one line, Recurum connects Web3 professionals to Web3 companies through Web3 events. Today we have more than 200 plus jobs active and are being offered to you on this event. On today's masterclass, we are also offering you NFT minted certificates to all participants who stay till the end of the event. So if you're joining this event from anywhere across, like let's take YouTube, LinkedIn, or Twitter, you're watching from any stream, jump onto the Decorum website, log into your ID, join the discussion room, and drop in your wallet addresses in the chat room. I repeat again, we're offering 200 plus jobs and NFT minted certificates. I'd also like to acknowledge today's sponsors as well as our partners. Today we have a company which helps various other, Web3 companies audit or understand what their companies are doing in Web3 basically. Today, we are working and we have a masterclass with QuillAudits. It is a leading smart contract auditor firm and is completely committed to securing blockchain solutions and cutting edge, projects in the Web3 security solutions. They provide auditing and decentralized apps penetration testing services for Web3 based DeFi and NFT projects. Today we have Prajwal, a smart contract auditor from Quillhash, QuillAudits, with us, and let's welcome him on the stage. Prajwal. Hi,
Hey,
Prajwal.
hi. Hey, hi, Laksha. How are you?
I am doing perfectly fine. Can you hear me?
Yes, yes, I can hear you. Yep,
Awesome.
you're audible.
Hi, Prajwal. How are you doing?
Yeah, I'm doing good.
Great, great. So, Prajwal, today we're talking about, why is it important to have smart contracts and audit smart contracts for security solutions, correct? Why don't we start there that what does Quillhash actually do? Like, what is auditing of a smart contract? Let's start with the basics
Mhm,
and let you tell the audience here today that what is smart contract auditing.
mhm. Okay, so about smart contract audit, it isn't a magic but time-boxed approach followed to find bugs that can be there in code, that can be there in logic, or maybe the code is not working according to logic that is required or according to
Okay.
business logic. So basically, there can be many processes like manually auditing it, then automated testing for the smart contracts, and again documenting these issues found in report. So again, there can be many iterations to fix that issues and patch them, and then the projects can go live basically. But yeah,
Okay, so
this was just high level overview of it. Definitely,
mhm.
there are many things in low levels. Working.
Right, definitely. So, keeping us very simple understanding, it's basically you're adding on that final touch to a smart contract by seeing it in detail, by solving bugs, ambiguities, whatever is there. Correct?
Yeah, yeah, yeah.
Okay, awesome. So with that, let me move ahead and ask, like, when did you join, QuillHash, or like how Quill audits? Okay, and what has your journey been? Okay, how did you end up being a smart contract auditor? And whoever wants to become a smart contract auditor, how should he choose his path? Let's take someone who's just out of college after his
Mhm.
BTech.
Okay. So the answer to the first question, when I joined QuillAudits, it's basically the start of this year, uh, uh, like 2022 January, and basically I started as intern and completed internship, and now I'm working full time basically. About your second question, how someone can join us as an auditor, or how someone can learn smart contract security. So definitely there can be many ways, but there can be many roadmaps. You can create your own roadmap if you want. Um, but basically, the thing is learning some things first that can be used in development, then learning
Okay.
about security perspective, like what are things needed from security perspective. If there's something, let's say for example, if there's NFT smart contract, uh, how it's working, and uh, what can go wrong if there's bug, or how basically we can think from security perspective. But again, this is not a roadmap that I'm telling, because it's not possible to tell a whole roadmap in one line basically. Yeah, but this is how someone can do it. And
Mhm.
yep. But yeah, I would definitely I would be sharing the maybe link to one roadmap, so viewers can take a look.
Definitely, definitely. So, Rajul, to understand this, someone who has been in the field of cybersecurity, maybe, or maybe in someone who understands how to debug code, okay, they
Mhm.
is that a prerequisite to become a smart contract auditor, or like are there any other more prerequisites also?
Okay, so if you're talking about cybersecurity, you mean if someone is working in Web 2 cybersecurity and
Right,
he wants to join as, or he wants to be a smart contract
smart
auditor,
contract,
like
right,
yeah, like Web 3 stuff related, and
right,
related to security. So definitely, uh, they have what we can say offensive perspective to break the code of others. If they're coming from Web 2 security, again they can learn some development things.
okay,
For example, when we talk about solidity, they can learn how to develop solidity smart contract. Again, uh, uh, you can learn about full stack also. So but again there can be other type of attack vectors, so which won't be only related to solidity, but again something where the integration of Web 2 and Web 3 is going to be, there can be any other type of attack vectors. So yeah, these things can be useful. Again, there can be any guy who is let's say for example full stack developer, and he knows DeFi concepts really well. uh, it again it depends on how you take that. Yeah.
okay, okay. So, tell me this, Prajwal, what actually fascinates you, or what is that thing that amuses you for smart contract auditing? Like something that like something which is amazing, which you feel which you can do every day, because that is what you're doing every day, right? So, what is it?
Mhm.
One thing which calls you that this is something which fascinates me. This is very surprising. So this brings that kick that I have to continue doing this smart contract auditor thing.
Mhm. Okay, yeah. It excites. There can be. I mean, there are many people who are enthusiastic about it, and I like to be enthusiastic about these things. So it can happen, like looking into code and breaking
Okay.
them, talking with our mates, or let's say, for example, co-auditors that are working on the same audit, and then just basically talking about these things and meeting with like-minded persons. These are the things, but not limited to this.
Okay, okay, works. Okay, Prajwal, let's go ahead and give a little more a simpler understanding maybe. Okay, because I have seen most of the people who usually watch our master classes mainly are freshers, or maybe people who are trying to enter into Web3, and plus our master class also states transitioning into Web3. Correct.
Mhm.
So, would you like to give a simple understanding of what is a smart contract in layman terms?
Mhm.
So let's take
Mhm.
the audience. Like, let's say you're teaching me what is a smart contract. Okay,
Yeah.
let's go with that. Like, see, as much as I understand, it's like an agreement. Okay,
Mhm.
but I'd like you to take the lead and explain it a little more in detail.
Yeah, sure. So basically, as you said, in layman terms, uh, we can say that it is program that running on blockchain, uh,
Okay,
and which can execute or perform some certain actions according to code that is there. But
okay,
obviously, human interaction would be needed first, and then it can happen.
okay, okay. So it's basically a simple stack of code on chain, correct?
Yeah.
But what is the purpose of it? Like, what does it
Mhm.
signify? What does it do?
Mhm. Yep. So basically, it can do whatever you want. For example,
Okay,
you want to code NFT, you can code it.
okay,
You want to code ERC20 token,
okay.
definitely you can code that fungible token. So it depends on what developer wants to do. Uh, there's a way available. Yeah.
Okay, so to understand it more simpler, it's a way of interacting with the blockchain. Correct?
Yes. Yeah.
Yes.
Interacting
So
with
it's
blockchain, sometime reading state, sometime updating the state of smart contract. Yeah, or blockchain.
okay, okay, works. Understood. So it's basically you can create your own anything that you want, let it be an NFT, let it be a token, let it be a coin that you want to launch. Correct? And it's
Yes.
the smart contract is simply an interaction with the blockchain to make that happen. Okay, it's
Yes,
basically
we
a
can say that.
transaction, if I may say, in simpler words. Okay,
Yes, we can
awesome.
say that.
Definitely, definitely. So, Prajwal, what do you think about today's topic? How would you want to start today's topic?
Okay.
Give a
Mhm.
basic head start to it, and then post that we can maybe enter the version where you explain the whole thing through a PPT.
Mhm. So today's topic, so basically, it is about introduction to smart contract security. Uh, so we would be going through some. I would share the PPT presentation, and we'll be going through some points. But it's just
Okay,
not PPT. We will also go through some code examples, which would be more
okay,
explanatory, I think. Yeah, about
okay,
need of
awesome.
smart contract and yeah, vulnerabilities.
So it's simply more about what is the importance of smart contract auditing,
Yeah.
what it is actually, and how it is done. Okay, with some use cases, correct?
Yes. Yes. With some
Okay, awesome.
vulnerability. Yeah.
Right. So Prajwal, are we ready to start? Shall we start?
Yes. Sir.
Okay, so you can start sharing your screen now, and we can
Mhm.
head towards you explaining about today's topic.
Yeah. Sure. Okay. Uh, I hope you can see this.
Just a moment. Yes, your
Mhm.
screen is visible. Prajwal, you may start.
Oh yeah, sure. So as I said, it is about introduction and importance of smart contract security. Mm, Mhm. So let's start with what is it. Um, so smart contract security is basically a research area that deals with security issues and basically that arise during execution of smart contract in blockchain system. So again, it as I said, it's not a magic, but a timely approach followed to find known vulnerabilities to ensure the code is written according to requirement. So it can be, let's say, for example, there's a function to transfer some tokens to another address, and the requirement is it should deduct some fees. So we can say that this is the requirement, but there can be a bug which says that, or which is basically about it just don't deduct fees when someone is using another functionality. Let's say, for example, transfer from function. So this is it when I say about uh, requirement. Again, importance of it. We can see some numbers here. So this is you can see $718 million lost to Web3 hacks. So in 2022, and it's Q2 basically. So if you see this stats, basically you can see. Uh, so these are basically uh, from all the components and layers. So if we compare other things with a contract layer, or let's say, for example, this component, then you can see uh, the thing that is getting attacked more is this smart contract, and uh, obviously that don't mean keep you don't need to audit other things, or you don't need security for other things. You obviously need security for other things, but again, looking at the stats, it shows more importance to this, as this would be gateway sometime to uh, update the states if we talk technically. So again, I have added some uh, basic attack vectors, so we can just take a look at them. Um, Reentrancy attack. So this is first one, basically that we have added. As it says, reentrancy. It is reentering into a transaction flow.
Um,
Uh,
Hi, Prajwal.
yeah.
Yeah, Prajwal, we're only being able to see the um, PPT screen, like the PowerPoint screen. We're not being able to see the other screen that you're sharing.
Hmm. Uh, okay. So
Yes,
you can't see this screen.
we
Basically,
can see
just
the
give me a.
screen, but it is only the PPT, like the Microsoft
Mhm.
PowerPoint screen. Okay,
Okay, I
if you
think.
are sharing another screen, you might have to try full screen mode.
Hmm. Okay. Yeah, I think now you can see this.
Okay, do you
Maybe you
mind
need
to
to.
stop sharing and resharing again?
Oh yeah, sure.
Yeah, yeah, you could try sharing again.
Hmm. Hopefully, it would be visible now.
Yeah, let's just wait a moment. Yes.
Hmm. Yeah,
So
yeah,
if you
that's
have
right.
written a query, you mentioned about writing a query, or some syntax, right? Um,
Code.
yeah, yeah, yeah. We actually weren't being able to see that.
Hmm. Sorry, can you repeat again about which code you were asking?
See, we are
Or-
currently on the re-enterancy.
Yeah, yeah, reentrancy attack. Okay. Yeah, yeah.
Exactly, we're on that page.
Hmm. Yeah, sure. So
Okay,
basically, I would be starting from this. So this is the
sure, sure.
first
Go
slide
ahead.
in attack vectors. Okay, so I'll start it again about reentrancy attack. So as it says, it is about re-entering into transaction flow, maybe as many times uh, to uh, maybe to make a profit. So it is uh, basically when it occurs, a reentrancy attack can occur when a function makes an external call to another untrusted contract. Then the untrusted contract makes a recursive call back to the original function in an attempt to drain funds. But maybe it won't be the uh, this reason many times to drain fund, but maybe to uh, DOS another user or someone. So it can be anything. Looking at some code examples. So first of all, the type of reentrancy. When you talk about reentrancy, there can be a single function reentrancy. For example, there is a function. Let's say, for example, withdraw function, and for this, what it's doing is it just, for example, this contract in which we can deposit some amount of ethers or native token, native blockchain token, and then we can withdraw it after some actions maybe. So this uh, withdraw function can be used to withdraw that amount that we have there. So when you talk about this function, what it is doing is just getting balance, just looking into balances mapping and getting this amount that this method sender would be having. And it's basically checking that uh, first of all, this checking the output of this call. Now, what is this call? Is basically this sending the value or this amount that someone has here to the message sender. So if that message sender has, let's say, for example, one ETH staked or maybe deposited, then it would be sending that to that address. But here the catch is it is using call functionality, or let's say call low level call. Here this can act maliciously, not call itself, but when you talk about uh, someone is receiving token or this native tokens, for example ETH or BNB, um, they can have some methods like let's say, for example, fallback method, and which would be executing fallback or receive method, which would be executing on certain actions. Like receive method would be executing on if some funds are received into smart contract, and attacker can basically add the malicious code to re-enter into this transaction flow. So it sends amount to attacker contract. Let's say, for example, this message sender would be attacker contract, and it will re-enter again into this transaction flow. And now here, the state of this balances mapping for message.sender address has not been set yet. So once they re-enter here, uh, they'll get this amount, which is still the amount that they deposited. The, let's say, for example, attacker or message.sender in this case, and they can keep going again and again. Uh, but still there can be limitations, for example, from gas perspective, or how much amount they have staked here. So this is it. Basically the basic thing that is happening here is this state or this uh, state is getting modified after the external call, and this call is basically uh, we can say external call, but it is a call that is giving attacker uh, ability to re-enter into transaction flow. So as a precaution, many things can be done, but the one thing that can be done here is following checks effect interaction pattern, or in simple way, basically, if we say that this balances mapping for message.sender address, we can set this before making this call. And if we do that, what will happen is before sending uh, this amount of token to someone, let's say, for example, ether to someone, uh, this will get executed before. so that uh, even though they can re-enter into this contract and function transaction flow, the amount is already zero, so they can't uh, withdraw more token than what they had deposited, basically. So going through this cross-function reentrancy, uh, which is again a type of reentrancy. The In the first example we saw, it is the attack is getting carried out with only one function, but here we can see there are two functions basically. Um, so let's see if, for example, this function is to just transfer the amount of token, and what it's doing here is just updating the state for this balances mapping. So for example, if someone is sending some amount of tokens to two address, it's just uh, checking that the amount that you want to send is greater than what this balances mapping has, and which maybe is getting updated when someone is depositing token. So here, what it's doing is just updating uh, the value for balances 2, and it deducting the amount from message.sender, because message.sender would be the one with sending amount uh, to address. Coming to the withdraw function, it is doing a little bit same thing. If we see, it's just getting amount and sending it to the message.sender, and uh, checking the written value given from this call. So it would be true, and if it's not, it will fail. And again, it's doing the same thing that is here. It's setting the state after this uh, call for sending tokens. So here, maybe for example, reentry can happen in the way that, let's say for example, if now as we saw, uh, this thing is following, if this thing is following, let's say for example, check effect interaction, which would be setting this balances mapping to 0 before this call, then what can happen is, then as we saw in this first example, attacker can't re-enter, and because of that, maybe that attack won't be possible here. But again, if we see this function, it's possible for this function to transfer the amount that someone is having here uh, to that address. So it can happen that while withdrawing this token, attacker gets the amount of ether he deposited, and now he is able to re-enter maybe by using withdraw or receive function, and uh, maybe by using receive or a fallback function, and then again sending this amount to that to address. So in this case, it can happen with both the functionality. So it's cross contract, it's cross function reentrancy, where it shows basically that the attack is getting carried out with uh, the functionalities that are basically two functions, not one. But basic idea is the same here. Uh, it Attacker withdraws a token, and he gets the call, and then he's able to re-enter into attack. So it is important to check not only the function, maybe that is, for example, withdraw function in a contract, but to check other functions, for example, this transfer function from which the tokens can be transferred in this case. Again, there can be cross-contract reentrancy. Is basically, we haven't added example here, but it is about a contract that is sharing state with another smart contract, and that functionality is dependent on the state of another smart contract. So let's say, for example, there are two smart contracts, contract A and contract B, and contract B is basically maybe holding some state, and contract A is dependent on that state. state. So if in some cases, if attacker is able to manipulate that state, it can happen. It can create some scenarios where the attacker can re-enter into the transaction flow. Mm. So again, can reentrancy happen without sending it? Definitely, if we are not only talking about, or let's say, if we are not sending any native token to any contract. So, for example, there's no use of fallback or receive function as we saw in these examples. So, uh, there's a diagram on which we can see. Let's say, for example, this is the contract or piece of code that is uh, offering the functionality for claiming NFTs. Now, in this case, say for example, uh, this is attacker basically. Attacker creates a contract to claim that functionality. Sorry, the claim that NFTs that maybe they have bought, and then uh, it is a simple thing that it sends NFTs to attacker contract or the address that maybe that specific address that is mentioned there. So here, basically, reentrancy it depends on the code. So let's say, for example, if there's any hook or there's external call happening, or the call happening to this contract, which may be having malicious code and which again can re-enter into the transaction flow and exploit it to make some profit. I would like to share my another screen so we can go more practically through example. May I?
Yeah, please, Prajwal, go ahead.
Yeah, sure. Just give me a minute.
Sure.
Hopefully, this would be visible. Let me know once it's visible. Hello.
Yeah, it is definitely visible.
Okay. Okay. Then again, it would be more explanatory to go through code. So if I talk about this contract, this is doing the same thing. Uh, Let me just access this contract. So it is a basic contract having ERC 721 functionality. Uh, it is NFT contract that means it mints some NFTs to address in simple way. And how it works is basically first user comes, they send some value, for example, amount of ether or whatever the native token would be, and this mapping, which is can claim mapping, this the state getting updated here for message.sender, and we're setting it to true. And when it's getting used is getting used here when someone would be claiming the NFT. Let's say, for example, someone comes here, purchases NFT, and then again claims it. So this is the simple uh, flow of this contract, and now we can see how it can get exploited, uh, basically. So here, for example, this claim contract function is offering functionality to claim NFTs. Again, let's say, for example, um, someone buys NFTs and then initiate the process for claiming. So here, if we see, it's checking that the can claim should return true. That means that someone who would be calling this function is having something about, or they have uh, this can claim mapping set to true for their address. That means they have purchased the NFT, and it's just checking the same thing. So again, when we come here, it's safe minting the total supply, which would be definitely here one number, so which would be like ID for that NFT. Once they are safe minting this to this address, there's a difference between mint and safe mint functions. So we're talking about ERC721 safe mint functionality. So I would like to open that so we can better uh, understand this. We were talking about this thing. What it's doing is it's minting the NFT uh, or the token to that address, and it's checking other thing also, and that is if the address for which we are sending NFT to is supporting basically like to, so it checks that if that address can uh, first of all it checks if that address is contract address, and if yes, then it checks that if that contract can handle NFT. And why is that? Is because it can happen that you send NFT to any contract, and there's not having NFT or supporting the functionality to send it somewhere, so the NFTs will get stuck. So, and that this is what it does. But basically it makes call to that contract and checks for this specific byte code, which would be a selector. So it checks for specific output, and if that call returns the uh, expected output, which would be the selector for this on ERC721 received function, then it continues. Otherwise, it will revert. So again, coming to this NFT contract, which is offering this claim functionality. So here, as we saw, there's a call to this message.sender to actually check that if this can support that NFTs and can handle NFTs, so that it they won't get stuck there. So attacker can use uh, this way to re-enter into this transaction flow. As you can see, this safe mint is again checking on this address that if it's executing a similar method that is on ERC received, and then basically it's calling into it and checking if it's returning the expected outcome. So attacker can create this smart contract with malicious intent to, let's say, for example, in this case, to claim some extra NFTs. And he can simply create that contract with this. He will inherit this functionality just to get the selector, and which will return here, which is expected uh, here in this contract here. So we were talking about this uh, exploitation of this a vulnerability. Uh, so attacker can write the contract in the way that once this smart contract here, first of all, this message sender, if this message sender is smart contract, then it will check that if it will call this method on that contract and check for expected outcome. So here, attacker can do some malicious things. For example, calling that contract that is offering claim functionality again here and claiming the token. So here, if this while safe minting tokens, if attacker can re-enter into transaction flow and can claim more tokens, then again this is reentrancy, the case of reentrancy where uh, again check effect interaction. Basically, the state effects are happening at the after the call or external call, that is basically call in this case, which is making some external call and uh, which is letting attacker to claim more tokens than what he have bought. So basically that was the intention of this contract to do. So we can quickly check this test. So this is again what attacker can do is he can create this attacker contract which would be having this function to re-enter into the transaction flow. Now here, mm, if you see, this is the basically Foundry project. So I'm writing test in Solidity. So if you see this attacker contract instance, uh, uh, we're making, we're just uh, basically transferring some, let's say for example, tokens to it. But the main thing here, it is required because the attacker contract would be the one who would be buying these NFTs. So attacker contract would be calling this buy NFT function and would be sending some uh, value to this function so that we can have NFT. So and we can claim that. So coming to attacker contract and showing this method, which is basically calling that buy NFT with while sending some value so that we can have NFT, and then it's claiming that. After claiming, it will basically safe mint that NFT, and while safe minting, the attacker can re-enter the transaction flow using this malicious code here, and again can claim this functionality out here, uh, claim the token through this functionality. And here, this is just asserting to check that if attacker contract, the balance of the attacker contract is 2, because in this case where attacker is spending 1 ether only, he should get 1 NFT, but in this case he can mint any amount of tokens. Obviously there would be some limitations looking at the gas. So this is about reentrancy. Let's I'll share the screen again and we'll move towards another attack vector. So next one is front running. I think it would be better if I can share all the screen, so there's no need to share every screen. So let me know you can see this.
Yes, yes,
Mhm.
I can see this. You can continue.
Okay, yeah. So for now, I'm sharing all the whole screen. So just give me a minute. Um, Talking about front running is basically front running means uh, front running the transaction. So sending a transaction before any transaction. Uh, it takes advantage of process by which a transaction is added to the blockchain basically. Some applications, now applications means not literally applications, but how it may be applicable to exploit some scenarios. So let's first talk about uh, this proof race condition. Hopefully you can see my browser.
Yes, we
Mhm.
can.
Okay, so when you talk about approve, this is basically ERC20 implementation. And what's happening here is if we see this code for approve, then when we approve something to someone, that means we are allowing the spender to spend token on behalf of someone and on basically on behalf of the one who is allowing them. So here, let's say, for example, first of all, someone is approving 100 ERC20 tokens. So it will set this mapping for, it basically maps address to address type and then UN. So it just assigns the amount to this mapping here for owner to spender. So let's see, for example, 100 ERC20 token, but now after approving tokens to any address, we we check that okay, we don't want it to approve 100 tokens, but we want it to approve 200 token list, for example. So here, uh, let's say for example, we again approve 100 tokens to let's say example for example, we again approve 200 tokens because we wanted to approve 200 tokens. So here again it will assign that amount to this mapping. So here, because of public nature of blockchain, uh, basically anyone can see the transaction that is coming from this address or any address. In normal cases, what can happen is if let's say for example attacker knows that there is going to be a transaction, or maybe he's monitoring for transaction, for upcoming transaction from the address who is going to approve, and he now sees that there's a transaction for approving 200 tokens. Now first he would be having approval for 100 tokens, but now he can see approval for 200 tokens, which would be a transaction. Then here he can front run the transaction for which basically is to approve 200 tokens. And then after front running this transaction, um, that attacker can basically spend this amount of token that he's having in approval uh, from this owner, and it will again receive this new approval for 200 tokens, and he can again spend that. So in total, he spent 300 tokens, 200 plus 100. So here, what happened is this is what front running is basically. The front running checking, basically monitoring and front running the transaction. When you talk about exploiting it, this is the example of exploiting the front running scenario, uh, and which you can see this in this approved risk condition. So again, as a mitigation for this approved risk condition, normally there are other functions added here in this implementation. For example, increase allowance. So what it's doing is, while allowing new amount, let's say for example we have approved 100 tokens and we want to approve 200 tokens. So now we know that we have approved 100 tokens, we want to approve 200, so we'll add 100 more, and after that it basically again calls approve function, but here it checks the amount, the approval or allowance amount that this spender is having. So let's say for example spender front runs our transaction, and uh, maybe he uses this allowance first, and after that our transaction to increase allowance executes. In that case, this allowance for owner to spender would be 0. So 0 plus the value that we want to add or increase here, that would be 100, because we wanted to make it 200. And this basically helps to, even though as we saw here, even though he can spend his allowance, but still what we are not assigning the amount to uh, spender, but we are increasing the amount by checking the previous allowance. So this is the thing here. And another application would be in sandwich attacks, which is basically front running the transaction and back running them to make profit. For example, if in any trade uh, the attacker monitors the transaction coming, and which is maybe maybe manipulating the amount in the pool, and if attacker can front run the transaction, the victim transaction, and can back run the transaction in the way that they can make profit, then that would be successful, we can say, sandwich attack. So I think this is for front running attack. Weak source of randomness. When you talk about randomness in predictable systems, uh, it's basically not possible. We can uh, maybe generate random numbers, but they won't be truly random numbers. So there can be need of random numbers, for example, smart contracts like lottery or games to maybe to generate some lotteries and uh, to basically whitelist some user. So here, there are some global variables or attributes that we can use. For example, block.timestamp here, or block hash or block number, or Coinbase. So let's say, for example, there's a smart contract, and which is calculating this randomness with this these things. So let's say, for example, block.timestamp. So the way it's calculating randomness is publicly visible, and attacker can see that, okay, this is using block.timestamp and maybe multiplying this with some other things to make any random number. But again, because of public nature of blockchain, anyone can see this and predict it before that. So it can result in mostly in several outcomes if this thing is getting used for uh, the way where truly randoms are needed. Uh, then we have asserting EOA from code sides. So there can be a need, or I can't say need, but sometimes it happens that uh, a developer wants that maybe other smart contracts should not communicate, or I mean should not call some functions. I mean they can definitely call, but they want to revert these transactions. So in this case, sometimes they use the thing called, or basically the core size of caller. And basically let me just go through this also. uh, so basically when you talk about EOA, it is externally owned account. That means let's say a user wallet, and that is not a smart contract basically. So this user would be interacting with smart contract, and the function wants to check that if user is EOA and not a smart contract. So there can be some scenario where they can use this thing, but not that much safely. So let's say if there's a function which is just checking the code size, and here the length of this basically member of address, and if it's not zero, then it's reverting. That means if it's not zero, then it's not EOA. So EOA won't be having code on it, because it is externally owned account. It is a user wallet, and smart contract can definitely have a code on it. So this way sometime this way get basically can be used, but as I said, it is not that much safely. Again, the same thing is happening here. Uh, while minting this, it's just checking that uh, this is calling is contract, and checking expecting that the output should be false. And what it's doing is doing the same thing, but in a low level in assembly. So it's checking the Xcode size. Basically this is a code, and it is getting used to check the size of the code at that address. And if it is greater than zero, that means that is contract. So here there's way around it. Basically when this in this type of scenario, it can happen that attacker can use basically a smart contract to and can explicitly write constructor there. So in contract creation, the if any functionality or checks the code length of object, or the size of that basically the code at that account, it would be zero while contract creation. And it can happen that the attacker can call uh, this functionality through contract creation, which is through the constructor, and maybe would be able to pass these checks even though it's not EOA, but using the smart contract. So that's why it's not recommended to use this checks. Uh, so basically, there's a solution to it, but it's not a foolproof. So we can check that message.sender is transaction.origin, and to understand what is it, we can see this diagram basically. So this is EOA, user wallet, and it's basically making call to this contract. So when it's making call to this contract, the EOA, the message.sender would be EOA, and transaction.origin, which would be basically the origin of transaction, or the address was initiated the transaction. The both would be EOA here, but this contract for B contract B, the contract A is making call to B contract. So for here, the message sender is contract A, which is immediate caller of for this, and the transaction.origin is EOA, which is this. So again, it can happen that this contract is checking that the caller should be EOA only, but because this contract is getting calls from this contract A, and this functionality is here where it is not possible because maybe that project would be using this as a main contract, this is as a helper contract where it's making call to use the code from here, and it can happen that the call will definitely fail because of the way it's checking for if the caller is EOA or not, because here it can't access this way basically. So again, there are many limitations, and practically it can be checked like this, but again, it's not a very better way to check it. Moving ahead, so transaction dot basically authorization through transaction dot origin. So it is a very well known uh, bug basically. So what is transaction dot origin? As we saw here, uh, it is the origin or the address from where the transaction got initiated, and so why it's not safe to use text.origin for authorization. So we'll understand it with some examples. So I have this example here, and what it's doing is it basically a contract which has a constructor and this uh, transfer. So for example, let's say this using this we can transfer some amount of ETH or native tokens to some address, destination address, and let's say for example someone having 100 tokens, someone can transfer some amount of token from that to this destination address that we can put here. um, this functionality can get exploited basically because of the thing that I told, that is it's using text.origin, and the way that maybe attacker can follow to exploit this uh, contract is this. So if let's say for example address A is transferring tokens to address B, so this for example address A is transferring ETH to address B, and address B is this attacker contract. So it's basically deployed by attacker to exploit this vulnerability. So what it would be doing is, let's say for example, there is a fallback function which would be reacting when it is receiving ETH. Now here the message.sender uh, would be the contract address. Now here owner would be the owner is getting set in constructor. The this would be attacker because it will be deployed by attacker. So let's say attacker basically receives this token, and and this function gets executed. So the message.sender here uh, would be this takes user wallet contract, and it is calling this transfer to function. We're using this interface here to uh, basically communicate with this sorry with this address. So if this the attacker can while receiving token, if they can make this uh, call transfer to, and if they set this uh, destination address to owner, which would be this owner, in this case this address, attacker's address, and the balance that maybe the attacker wants to transfer is the balance that this contract holds. So here, if we see this transfer to function, it basically checks that tx.origin equal to owner, and once the attacker executes this function through this fallback function, uh, the owner parameter here would be attacker's address. So again, coming here, so it will check that this the destination is this attacker address where the token needs to be sent in this case, but and the message sender is the the message sender would be the address here, this address, and we're just accessing balance as I mentioned before. So here, after that call, it is just checking that transaction.origin was owner, and here the owner is, let me check it again. So here, the transaction was executed by the original owner to send the amount, and it can happen that it will pass this check because of that, and this can again transfer to the amount to destination address. The amount here would be the amount that this address is holding. So in this case, we can fool the this functionality. So it's better to use message.sender here in this type of scenarios. Talking about some solidity best practices. So using assert and require properly. So the assert function should be only used to test for internal errors and to check invariants. So again, you can see in many cases the assert is getting used where there's maybe for writing invariants, and maybe that will get uh, uh, violated to check if there's any bug. Then require, it should be used to ensure that valid conditions, for example inputs, and maybe for checking some conditions, some states. Using modifiers, using modifiers only for checks. So this uh, ensures that the code inside the modifier is usually executed before the function body. So any state changes the external call and will violate the check effect interaction pattern. So explicitly mark visibility in function and state variables. So when you talk about marking visibility in functions, uh, normally when we talk about public and external functions can be called externally by anyone. So if these functions are holding some critical functionality that should be only called by owner, then it is required that to uh, maybe to use some kind of modifiers there, or maybe if this functionality should be uh, if it should be private, then we can define this as a private instead of making it public so that anyone can't call. So state variables again, this don't matters here much, but for maybe for following some good practices, or if you think that from object oriented perspective that uh, any contract should not uh, let's say for example not be using the variable that you would be having in the current contract, then you can definitely follow this pattern. uh, then locking pragmas to specific compiler version. When it comes to locking pragma, it is basically better to use latest compiler version. But let's say you there's a unlock pragma, and maybe it can get deployed with any compiler version with which you haven't tested this contract. So it can happen that it can go some maybe in unexpected way, but this again matters if there's any bug in upcoming compiler version, which would be less likely. Then using events to monitor contract activity, if there's any critical things then happening through this function calls or contract activity, then we can definitely use some events uh, so that other user or maybe some web2 infrastructure can be deployed to access this event and can be showed it to uh, on maybe on a client side, or what I can say is basically on UI side. The last is avoid using this transaction origin, as we discussed. It can be used for phishing, as we saw. So that was it basically. And some resources from which I have taken some things like this one Karen Zipfeld's repository. Uh, then definitely you can see many examples on this smart contract programmer YouTube channel, or the roadmap. Many people ask for roadmap. I think this would be uh, a good version of roadmap, but again I will encourage you to go through some other resources also, because it can happen that one resource contains all the things because the technology is evolving rapidly. Then for the example that we saw about uh, safe mint reentrancy, you can access that the write up about that on this uh, Medium profile. And again, last point is do your own research. Is basically things are getting outdated sometime because of things are evolving. So some content out there maybe get outdated, so it's a good idea to check it practically, if it is still applicable, for example through running code or maybe with some way. I think that was it for now. Hello.
Just a moment. Hi, Prajwal.
Hey, hi.
I hope you can hear me properly.
Yeah, I can hear you.
Awesome, awesome. This was a very, detailed and very understandable session where, I believe anyone who's wanting to understand what is smart contracts, the importance, the auditing, the detail of, how you can someone work around the ERC20 token using a smart contract, everything that you have taught with the resources, it is very fantastic, very detailed, and definitely I have, learned through a lot. Would you like to say something about how was it for you, like the whole session?
Oh yeah, there was fantastic. I could highlight some things. Again, things
Okay.
that we written there are uh, not much practical things, but yes, some basic things for this session, which is about introduction and to smart contract security. So yeah,
Awesome.
that was fantastic. Yeah.
Definitely, definitely. But do you mind switching on your video? We're just in the last segment of our,
hmm I think
session.
it's switched on already. Yeah.
Yes, now it is. Definitely awesome. Okay, so Prajwal, let's move ahead with the questions. Okay, shall we?
Yeah, sure. Yeah,
Okay.
sure.
Okay. Can we have the first question on the screen? Yeah. Can automated tools detect all the bugs?
Okay. It basically depends. Mostly, automated tool it definitely helps. For example, running static analyzer uh, to maybe know some low-hanging bugs or just things, and then note it down to check it again after you start auditing.
Okay.
So again, there are other things like fuzzer or symbolic analysis,
Mm-hmm.
which would be approach to check the correctness of some properties. And when you talk about fuzzer, to just to further things, for example, uh, trying multiple inputs to the smart contract functions in the way that if many cases if they can uh, violate the assertions.
Correct.
Mhm. But as I said, it can be used for some things, but there obviously there's the human interaction or touch is needed, uh, basically to uh, analyze what's happening. For example, in business logic, so maybe
Okay.
it can't be understood well with tools.
Correct.
So
Okay.
yeah, they help, but they can't mostly find all the bugs or.
Everything. Right. Right.
Yeah.
Okay. Awesome. That's definitely sure. Okay.
Mhm.
Let's move ahead with the next question. Okay.
Yeah, sure.
Okay. How much time the audit takes, like normally? Like.
Uh, Yeah, so maybe it can depend company by company, and again, it depends on the code size. It depends on how much smart contract and about what smart contract is actually. So there can be a complex logic. So it uh, depends, but it can go to certain weeks to some maybe 1 or 2 months, depending on the code size and overall things.
Awesome. We have a question, um, so basically, it's like whatever. If it's a game NFT, if it's or different kinds of a staking NFT, so according to the timestamp difference, takes place, right? Like for different projects, it's a different timestamp, right?
Hmm.
Okay, okay, no worries. Let's move ahead to the next question. Auditing smart contracts ensure safeness of project, or are there any other factors when it comes to making projects more safe?
Uh, when we're talking about project, it can definitely it matters because when we talk about project, there can be many other components, not only smart contract. So there can be other thing, for example, uh, uh, any Web 2 related thing, maybe some APIs, maybe that they're holding some important data. So
Okay,
it really matters. That smart contract security really matters, but there are other components like this that I discussed. Again, if there's uh, anything, for example, uh, admin actions are important. It definitely matters from admin side to keep things safe. For example, they're using any wallet to access or to make these certain authorized actions. So it is really important to keep it really secure, so that someone just don't get it and just don't collapse all the things.
okay. This sounds good. This sounds good. Shall we move ahead to the next question?
Yeah, sure.
Okay. What benefits do projects get from choosing Quill audits compared to other competitors?
Hmm.
Excuse me.
Uh, Yep, we'll definitely say that there are some timing. It for response timing is fast, as far as I know, when
Okay.
it comes to responding to teams, and the waiting time is less.
Mm-hmm. Okay, so it's basically somewhere where as much as I know, Quill Audits works with a lot of companies parallelly. Correct.
Hmm.
So, in context to that, how does it go? If I want to understand in more detail, how does it go? So, let's take I am a Web3 company who reaches out to QuillAudits. Okay, now what happens?
Hmm. So basically, definitely, when someone reaches out to a company, uh, there are going to be some things that would be some business side. So I'm not that much sure about those things, but definitely I can tell you about the processes, maybe the
The
technical
process
processes
goes
that we follow. Mhm.
exactly.
So the it basically the auditors get scope.
Okay,
After that, they study it. They basically take calls with developers to understand code better, and then they follow some specified things with their approach. So basically, it can be manually analyzing the code, maybe writing invariants for that code so that some automated tools can take care of them. And it definitely then after all documenting whatever we find in a report, and then basically then after that, after patching some findings, or maybe if there's any critical issue, after patching these issues, uh, definitely we can move ahead with the iterations. So if there's everything good, then we definitely we will provide the final report.
okay, awesome. So, Prajwal, in similar fashion, we have a few questions from our YouTube community, our basically let's say Twitter community as well. So, let's go with the
Mhm.
questions from there. What are the top three smart contract security challenges?
Okay, so
Like basically, what are the
when you
main
talk
problems?
about challenges, then
Yes, the main problems
if
with
we're
that.
talking about CTFs or something,
So basically,
uh,
when you're auditing smart contracts, what are the
mhm.
main problems
Okay,
that you
the
face?
things that we face. Okay,
Yeah, yeah.
okay, so yeah, it can be definitely it can be uh, uh, the business requirement. It can happen. It's basically there's need to have smooth communication with
Mm,
uh, the developer team, or with the someone who have written the contract. For example, if contract is doing some things, then uh, uh, some auditor needs to know that okay, this is the thing that's happening, and for auditing this, this is what required outcome should be. So
right.
it again, it's not going to be big challenge, but again, having developers at the place, and you know just having meetings and calls to provide a certain for example explanation would be definitely helpful. So this is the one challenge. uh, Again, it can happen that from, let's say for example, there's a project that and they want to launch very soon, but they're not even having test cases. Let's say
Mm-hmm.
for example unit test cases, which is basically basic need from when it comes to any code. So it can happen that you'll find some things that are not working properly, for example broken functionalities. So if you want to send some tokens to someone, so it's not even happening. So uh, so these are things that will definitely increase the time of audit and overall efforts needed.
Okay. Okay.
So having
So,
these small things would be definitely helpful to fasten the process.
mm-hmm. Okay. In a similar fashion, we have a few more questions from the YouTube community as well. Okay, let's go
Mhm.
ahead with the second one. Are there any basic tools for auditing?
uh, Tools, yes, there are some tools. Let's say for example, when you talk about static analyzer, the slither is very famous there. uh, then when it comes to fuzzers, there's echidna. When it comes to symbolic analysis. I think I can say Manticore is there. There's Mithril. So yes, there are tools, uh, but definitely they can help to a certain extent.
Okay, okay. Um, Prajwal, we have the last question for today. Okay,
Mm-hmm,
and even I would want to know more about this. Okay, like does Quill like it's a similar question. Like, yeah, can Quill
mm-hmm,
audits do auditing for all chains, or like is Quill audits specific to a few chains
mm-hmm.
only?
Okay, 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 yeah. So as far as I know, the QuillAudits is doing audit for uh, let's say for example solidity smart contract. So if
Okay,
there's a chain that uh, there's a, where we can deploy smart contract with a solidity language, and the smart contract is coded in solidity, then definitely Quill audits can do it for it. And then I think it's for Solana, then Rust. So because Solana, it basically uses Rust smart contract. So yes, this provide audits for Rust also. The smart contract written in Rust. So for example, for Solana.
okay, okay. Okay. Prajwal, I guess we're almost to the end of the sessions. Okay.
Okay.
Uh, it was a very fine masterclass that we had today. I thank you for joining us today.
Yep.
And I'm really thankful to you, because I'm sure each one of us, even me, who has attended today's masterclass, it was very informative, very interactive. And, there's a lot to take back from today. Like I being a fully a person who's not into technical development, but I somewhere
Mhm.
also understood how smart contract auditing, or even development, the whole process that you showed through the PPT works. And before we wrap up for today's session, okay, would you want to say something to the community, like how was the session today, how was it, like what was your experience, how is it working with Decorum, or what do you think about today's session? Anything?
Mhm. Oh, yeah, so there's really a good session uh, to present maybe some at least basic things, but maybe that are required for someone to start just to start and know about some processes. So it's definitely good. And again, the things on which requirement is working, I think, is mostly about jobs and these things. So it's really the good, I think, so that
Okay,
others can
okay.
get chance.
Definitely, definitely. Thank you so much, Prajwal, for joining us today. Okay, it was a pleasure for me
Yep.
to host you today. Any
Yeah.
last thoughts before we close? Anything you want to say to
Uh,
the people? Anything?
mhm. uh, yeah, maybe I can just add a thing that I already mentioned, which is doing the own research. Uh,
Okay.
it can happen that content there is maybe online, it is outdated, or uh, maybe because of maybe for while transferring information, maybe there are some mistakes. So it's a good thing to check things practically. For example, maybe running through code, or at
Hmm.
least things that we can uh, understand and go through, or basically for asking questions. So it's a good thing.
Okay. Okay. Thank you so much, Prajwal, for joining us today.
Thank you.
I hope you had a good time, explaining and um, giving and imparting the knowledge to everyone that who has been listening today. Thank you so much, Prajwal.
Yeah. Thank you.
Good evening, everyone. So, I'm sure all of us had a very enriching and a very enlightening experience of knowledge today in today's masterclass. And I seriously hope that whoever had been active throughout today's sessions must have gained a good amount of understanding around smart contract auditing. This event would have definitely not been possible without the support that we had from QuillAudits, and even our partners and sponsors, and definitely we acknowledge them for the same. We at Recurum give QuillAudits a huge shout out for how they are helping different various Web3 companies, okay, work around their smart contracts, helping them audit them, and definitely they're doing a commendable job over there. So with that, okay, I'd like to extend my gratitude towards Prajwal as well, who has been very detailed, very highly uh, explainable on various grounds, on various points in the whole structure of today's masterclass. I would also request, whosoever has attended our event from various other, uh, online streaming channels, basically YouTube, LinkedIn, or Twitter, to come to the Rec Room website and drop your wallet addresses links in the discussion room at for this particular event. If by chance you have missed to see this particular event, do not worry. This event would be running for a full 1 week, full 7 days, and you can definitely apply and grab opportunities from various companies that have come to give you um, jobs, internships, and remote opportunities. Now, with that, I'm Laksh Mittal, who will be taking signing off. But before that, for those who don't know how they can mint their own NFTs, I'd like to recommend that we should use MetaMask wallet. MetaMask is basically an online blockchain wallet which will help you mint the NFTs that we'll be providing you. Okay, so it's as simple as possible. If you want, I can show you my screen. Just give me a moment. So here goes my screen. Right. So you can directly search metamask.io. Okay. And this is where, directly you can go to download, or like I'm currently using Brave browser. So you can download an extension to the Brave browser and create an account over there. Okay. As soon as you create an account over there, okay, it will be easier for you to mint the um, NFTs for all the events that we have currently been, hosting. So whichever events that you have, attended online on the Requiem particularly website, you'll be getting NFTs for the same. That is all from my side today. I hope you had a very detailed understanding for today's topic. We hope to host many other speakers soon. Okay. If you have, or if the community has more people who would want us to, host them, uh, reach out to us via any, social media channel. Let it be YouTube, Instagram, LinkedIn, Twitter, and we'll definitely try to bring those people on board as speakers to let them teach you about something very specific to help you transition into Web3. Thank you. This is Lakshmittal signing off.